Welcome to Hartman Math. This is lesson 6.4 Exponential Models. Warning, we are going to need a calculator today. So our first exponential model that we're going to use is just a standard exponential growth model. Y is going to represent the amount of whatever we're talking about later after time has expired. A is your initial amount. What did you start with? 1 plus R. R is the growth rate. We would need to change that from percent to decimal. And then T is your time. And we're typically going to talk about years, but it doesn't necessarily have to be. We could be talking about days or weeks if it is expressly done that in the problem. Typically our problems, we're going to work with years here. Example number 1, Nick's Christmas tree farm is going to be a growing business. Each year he increases his inventory by 9%. This year he will have 320 trees. How many will he have in 5 years? Let's set up the model. Remember, here's our model. Y equals A times 1 plus R to the power of T. We don't know what we're going to have in the future, so we'll just leave that as Y. A is the starting amount. We're talking about Christmas trees. So what's our starting amount of trees? 320 is going to go there. Our growth rate increases so that we know that's growing, 9%. So we're going to need to change that to a decimal. So right now, there's an invisible decimal right there. We're going to need to change it from percent to decimal. We're going to need to slide the decimal 2 places because percent means out of 100, and that's 2 decimal places. So we'd slide it here, and that would create a 0 there. So 0.09 or 0.09 is our R. And T, as far as the model, we're going to keep it as T to have it be a model. But we're saying in 5 years, so T is going to be represented by 5. So if we add these together, we get this. Now we're ready for the calculator. So we're going to type in 320 parentheses or times, your choice, 1.09 parentheses raised to the 5th power. See what we get. We are talking about trees. So it would not be appropriate to answer something like 417.3 trees, because you really can't have 0.3 trees as far as Christmas trees. So it really makes sense in this context of the problem to round to the nearest unit or the nearest tree. Let's go over and check out the calculator. So I'm going to type it in exactly as we saw it, as we'd simplified it. 320 parentheses 1.09 close parentheses raised to the power the up caret 5 equals 492. We would look after the decimal. It's not 5 or higher, so we're going to keep the 2 as is as far as our rounding goes and say 492 Christmas trees. 492 trees. All right, go ahead and pause the video here as you look through the population of Pi City, which is 22,906. There is a dessert factory moving in, so jobs are coming. The town's expected to grow by 17% per year. What will the population of the town be in 10 years? Again, pause here, work it out, resume when you're ready. All right, so we're going to say our model population equals, you could have left it as Y equals, that's fine. But I choose capital P for population, and then our starting amount is 22,906. The growth rate, since there's a decimal here, slide it 2 places, is 0.17. And our T is 10. And we'll go ahead and add these together to make 1.17. And then if you type that into your calculator and round correctly, we're going to get a population of just about, notice I used the wavy equal sign because we did round off, this is an approximation, 110,105. Example number 2, in 2004, a state had 112 golf courses. In 2010, it had 141. What was the growth rate? So we are talking about growth. We should use this growth model. Now remember, y is the amount later. So if the problem starts in 2004, later would be 2010. The amount in 2010, the amount later goes here. So 141 goes there. Starting amount, that would be the 2004. Starting amount is the 112 goes there. We don't know R, but we do know T. T is the number of years from this starting year to that year. So I think we're talking about 6. So now we're going to algebraically solve for R. We want to isolate. So first thing is to get rid of the 112. We're going to divide by 112, but we're not going to do it on the calculator yet. We're going to save all our calculator work for one step. Next, we need to undo the exponent. So how do we undo 6th power? We want to take a root. Which root do we want to take? We want to take the 6th root, both sides. Now normally, an even root like that, we'd want plus or minus. But we're talking about a growth rate, so we're really not looking for the negative part of this. So we're just going to do the 6th root on both sides. And then last, we got to get rid of the 1, so we're going to subtract the 1 on both sides. So R equals the 6th root of our fraction, 141 over 12. Once we get that, we'll subtract the 1. So there's a couple ways we can do this on the calculator. Let's look at that now. Let's try to put that into the calculator and see what we get. And then remember, that's going to come out as a decimal. We will need to change back into a percent for our answer. Let's take a look at the calculator. Okay, we want to take a 6th root, so we'll start by telling the calculator the index. And then we want to use the X root button, which is the blue one right here, not square root, X root, because we're going to take a 6th root. So 2nd up caret. Now because what we're taking the root of is not just a simple number, but in this case a fraction, we are going to need parentheses. 141 over or divided by 112. Close parentheses. That will finish the root. And then at the end, we are subtracting 1. And we get essentially the R. But again, remember, this is the decimal. And we want to change this back into a percent. So to go the other way around and go from decimal to percent, we're going to slide the decimal 2 places to the right this time. As before, we went from percent to decimal. This time we're going from decimal to percent. And we typically like to answer these to the nearest 1/10 of a percent. So 3.9, look at the next number to see if the 9 bumps up. It does not. So we're just going to say 3.9%. There we go, 3.9%. You try this one. How many clients would a business need to start with to end up with 100 clients in 4 years if this is the growth rate? Just a little warning, it's not identical to the last example. So start with your model, fill in what you know from there, and solve for what we're trying to figure out. Pause here, come back when you're ready. So here's our model. We want to end up with, so this is number of things, or in this case clients later, 100 goes there. What should we start with? So that's our starting amount, so we don't know that one, so we're going to leave that alone. Since it's 20%, if we slide the decimal over, that is 0.2, and our time frame is 4 years. So if we just simplify this part, hold off on the exponent, it's 1.2. Then this just happens to be a number, a times this. If we're trying to get a by itself, to undo the multiplication, we'll just divide by this. So now on your calculator, it's a pretty easy calculation. Just do 100 divided by 1.2 to the 4th power. That's going to give us our A, our starting amount of clients. Again, clients would be people. You really can't have 17.4 people. So in this case, we would definitely round to the nearest person. And you should come out to be, that's about 48. So 48 clients is what we would start with. Our last problem is a money problem, specifically money in an account of some kind, whether that's a savings account, certificate of deposit, some sort of an investment where you're promised interest paid on that account at regular intervals. So this is kind of a banking formula. The amount that you will have later is equal to the amount that you start with, P standing for principal. That's your starting amount of money. That's how much you deposit. Times 1 plus, again, R, same thing, or in this case, our interest rate. N is going to be the number of times that your interest is going to be compounded per year. And that occurs here and there. And then T is time in years. So again, A is the amount that you're going to have later. P is your starting amount. Call it that, the principal. How much did you deposit? How much did you start with? R is our interest rate, same thing as we were talking about before. And N is the number of times it's going to be compounded per year. Now, they're not going to tell you in the problem directly what N is. They're going to give you a code word. They're going to say, like, your interest is compounded annually. That means 1 time per year. That would mean that N is 1. Or another popular one is quarterly. So there are 4 quarters in a year. So N is 4 in that case. Monthly would be 12 times per year. Daily would be 365 times per year. Occasionally they'll say semi-annually. That's not a very popular one, but that's 2 times per year. Quarterly is 4. Monthly is 12. Daily, 365. Example number 3, how much money would you need to deposit to end up with $1 million in 25 years if this was the interest rate, which in terms of these days, that's a very high interest rate. Our interest rates are very low currently, which is good if you're borrowing money. It's not good if you're necessarily investing money. And we're compounded quarterly. So here's our formula, amount that we end up with later. Yeah, that's what we want to know. We want to know later, we want to get to $1 million. So that goes here. We don't know how much we're starting with. If we did, if we were trying to find out amount later, it's just a direct plug into calculator, no solving, just evaluate. But here, we're going to have to do some solving. Our R, we're going to slide it over 2 places, 0.0825. N is going to be 4. Quarterly means 4 times per year. That goes here and here. And then time is 25. So we probably are going to want to simplify this part here. What is 1 plus this? Don't do the exponent yet. Just figure out what's in the parentheses. That one would be a pretty easy one to type into the calculator and get that. And then here, your options are to kind of do this separately. What is 4 times 25? That one could be a mental math problem and just say that's 100. So now as we're solving for P, again, same situation that we saw before, this is just a number. Let's divide both sides by this number. So P will be this divided by this number. Now you can type that into your calculator. Since this is a money problem, money in an account, those problems are always rounded to the nearest cent. So 2 digits after the decimal if we're talking about finding either of these things. And you should have gotten that we need to start with $129,831.42 when you type that into the calculator. All right, the last one, this one's a little bit easier. You try this one. How much are we going to have later if we deposit $500? That interest rate compounded monthly. Give it a try. Resume when you're ready. Here's our compound interest formula. We're going to start with 500. Our interest rate, slide it over, 0.035 divided by 12. 12 times 4 is our exponent. Simplify this, multiply that, type it into the calculator, and get $575.02. That's it for today. See you next time.